So now we move on to the another cause of pre-stress loss, which is the still stress relaxation. So what is still stress relaxation? So still stress relaxation, which is usually designated as R, or simply still relaxation, is the loss of pre-stress when the wires or strands are subjected to essentially constant strain or elongation with time, which is actually the case when the pre-stressing reinforcement is being pulled by the hydraulic jack. So when the hydraulic jack pulls the pre-stressing reinforcement, it tends to impose or give a constant a constant strain or elongation to the pre-stressing reinforcement. Thereby, the pre-stressing reinforcement experiences what we call still stress relaxation, which actually causes a loss on the pre-stressing force being experienced or being carried by the pre-stressing reinforcement. So this is actually the reason why the applied jacking force is not usually equal to the uh, initial pre-stressing force that is being transferred to the concrete element that is being pre-stressed. Although actually still stress relaxation uh, is or I mean still stress relaxation happens not only on the time of jacking but also even after the transfer of the pre-stressing force, wherein the pre-stressing reinforcement tends to return to its original length, thereby imposing a compressive force to the concrete element. And the concrete element, as well as the pre-stressing reinforcement, because they are bonded, they both experience shortening, or what we call a constant uh, shortening, constant strain, making which makes the pre-stressing reinforcement lose some of the pre-stressing force that it carries. Or in other words, because of that relaxation being experienced by the pre-stressing reinforcement, it tends to lose some of the pre-stressing force that it carries. So if you can remember, if you will try to if you will try to recall, there is actually what we call a maximum permissible tensile stresses that can be imposed to the pre-stressing reinforcement specified by ACI 318M-14 and NSCPC 101-15. So you can see that maximum tensile stress on this table or in this table. So why do we want, or why do we specify a maximum tensile stress that can be imposed to the pre-stressing reinforcement? Actually, these limitations usually are applicable to the jacking stage, because as we all know, the pre-stressing force that will be carried by the pre-stressing reinforcement will will be coming from the jacking force that will be imposed by the hydraulic jack on the jacking operations. So according to the code, since we don't want our pre-stressing reinforcement to experience overstress, the code limits the maximum tensile stress or the maximum uh, tensile force that can be imposed to the pre-stressing reinforcement, especially at the jacking operation stage. So you can see those limitations here on the table specified on ACI 318M-14, section 20.3.2.5.1 and section 420.3.2.5.1 on NSCPC 101-15. And actually, the ASHTO code also specifies its own formulas for limiting the tensile stress that can be imposed to the pre-stressing reinforcement. So you can see those also in this table that can be found on section 5.9 on 5.9.3 on ASHTO 2012. So how do we get the actual magnitude of the, or the estimated magnitude of the pre-stress loss due to still stress relaxation? So for stress relief wires and strands, the formula for finding the pre-stress loss due to still stress relaxation is equal to this, wherein the FPI prime is the stress on the tendon or the pre-stressing reinforcement at time t, which is usually or must be in terms of hours after the jacking operations. And the ratio of this FPI prime and the FPY, the yield strength of the pre-stressing reinforcement, must be greater than or equal to 0.55, because if you can notice on the formula, if this value here will be equal, I mean will be less than 0.55, therefore we can get a negative value here, which is not actually the case for the magnitude for the pre-stress loss due to still stress relaxation. So we can't have a negative value there. So that's for stress relief wires and strands. So for low relaxation wires and strands, the formula is somehow similar to this. So you just have to change the denominator here by 4 to 5. And FPY that can be used here can be approximately equal to the 80% of the ultimate strength of the pre-stressing reinforcement for the case of pre-stressing bars, and can be approximated as equal to 85% of the ultimate strength of the pre-stressing reinforcement for stress relief wires and strands, and 90% of the ultimate strength of the pre-stressing reinforcement for low relaxation wires and strands. So those can be the value of FPY, unless if the question already specified a magnitude of FPY. Obviously you have to use that FPY that is mentioned on the question itself.